Welcome to Golden Software's video training for MapViewer 8. MapViewer is an affordable thematic mapping and spatial analysis software package that allows you to produce professional-looking graphics. In this video, I will cover how to create and edit symbol maps. MapViewer has three overarching map types: base maps, pin maps, and thematic maps. A thematic map is a combination of a base map and linked data. It shows different types of information, like social and political information, corresponding to a specific geographic area like a county or state. MapViewer has 14 different thematic map types, a few of which have subtypes associated with them. Each map type will be discussed in its own training video. This video will discuss symbol maps. Symbol maps are thematic maps in which a symbol is added at the centroid of the boundary objects, and the symbol is sized and/or colored based on one or more numeric data values. The example shown here displays a county map of Arizona, where the number of housing units in a county is shown as the symbol size and the population of the county is shown as the symbol color. Symbol maps, as with many map types, only require two data columns, PID and a data variable. However, many more columns can exist in the data file. Let's open a data file to view the formatting firsthand. Click File, Open. Use the drop-down list in the bottom right corner of the Open dialog to select DAT data as the file type. This will limit the file list to only show DAT files. Select the ky2010.dat file from the MapViewer 8 samples directory and click Open. The primary ID, or PID, is what MapViewer uses to link the data to the associated boundary object. This must be unique for each boundary object and must exactly match the PID of the objects in the boundary file. So for this file, columns A, D, and F would all be appropriate since they're unique. But the county files in the samples directory use the FIPS code as the PID, so we will use column A for the PID when we create the map. The data variable for a symbol map must be numeric data, so any numeric column from column G through the end of the file would work just fine. Now that we've seen how the data is formatted, we can create the map. Click File, New, Plot to open a new plot window. Click Map, Create Map, Symbol. If we already had a base map created on this map layer, only one dialog would pop up asking for the data file. Since that is not the case here, we will first be prompted to import the boundary file and specify the import options for the boundary file. In the Import dialog, select the ky2010.gsb file from the MapViewer 8 samples directory. Verify that the Show Options if they are available box is checked, and click Open. In the Import Options dialog, there can be up to two tabs. If the coordinate system of the file cannot be determined, the first tab, or only tab if your file does not support attributes, will be an Assign Coordinate Systems tab, where you can specify the coordinate system if you know it. Since our GSB file has a coordinate system saved internally, we do not see this tab. The second tab, or only tab if your coordinate system is known, is the IDs and Attributes tab. This is where you set the columns for the PID, SID, and/or hyperlink IDs, and determine which boundary attributes to import. By default, all attributes except the ones chosen for the PID and SID are selected for import. But you can click on these in the attribute list to select or deselect them. And you can click the Select All Attributes or Clear All Attributes buttons to select or deselect all of the attributes. We will leave the defaults and click OK. In the Open Data File dialog, you can choose the data file from the file list, or if you have the data file open in a worksheet, you can use the drop-down list under Use Loaded Worksheet to select the appropriate data file. Click Open and the symbol map is created. Now that the symbol map is created, it's quite easy to edit the map properties. The first step for editing the map properties of any map type is to select the map layer, so click on the symbol map layer in the Object Manager if it is not already selected. The map properties are displayed in the Property Manager. On the General page, we set the PID column and the variable column. The variable column refers to the variable being used for the size of the symbol. By default, this is set to the first numeric data column after the PID column. We'll go ahead and leave this set to column G tot-pop, which is the data column displaying the total population of the county. Since the map is a little dense, we'll also edit the data limits properties here by checking the box next to Use User-Defined Limits and setting the min limits to 50,000, so we only display symbols in the counties with more than 50,000 people. Now that we have fewer symbols, let's make them a little easier to see before moving on by choosing a lighter color for the boundary outlines and changing the symbol properties. On the symbol page of the Property Manager, we'll change the symbol to Symbol 2, so the thicker lines stand out against the background a little better. Now, we'll go to the Map tab, where the map properties are located. On the Map page, in the General section, we can choose whether the map changes the symbol size, the symbol color, or both to display the data values. In the Position section, we can choose where the symbol is located in reference to the boundary centroid, and we can change where the origin of the symbol is if desired. By default, the origin of the symbol is in the center. We'll leave this as is. In the Size section, we can set the symbols to be sized in a square root fashion or linearly. And we can set the minimum and maximum symbol sizes. In the Color section, we can choose which variable the color represents, and we can set gradients for the fill and line colors. By default, the color variable is the same as the size variable. We'll go ahead and change this to something different. In the Angle section, we can set the symbols to rotate uniformly within a fixed angle or from a data column. If we choose to rotate the symbols from a data column, we can choose to do so proportionally between a min and max angle. This concludes the Creating a Symbol Map tutorial. If you have any additional questions, please contact Golden Software.